Hello, and welcome to the ENEL400 preliminary design review for Group 7, consisting of Joseph, Thomas, and myself. Our client envisions a low-cost system capable of measuring a user's temperature and oxygen saturation. The temperature would be measured via a non-contact solution, and the SpO2 would be measured via surface contact. The measurements should then be presented to the user via a LCD screen and colored LEDs in order for the user to keep track of their measurements. We would need to disinfect the SpO2 sensor between every user, and for that we would use a UVC LED. The system will also be able to communicate over a network in order to send data such as the number of users that have used the station, and it will also be able to respond to a ping to check to see if it is powered and working. This is the conceptual system design. The microcontroller receives power from the power supply. It is then connected to all the other components. The sensors, such as the temperature and SpO2, will provide input towards the microcontroller, which will then calculate the user's measurements. It will then display the measurements to the user via the user display component and send a signal to the sanitize process to disinfect the SpO2 sensor. Finally, the microcontroller will also be communicating back and forth with the network connection component. Here's a block diagram for the user display subsystem. The microcontroller on the right receives inputs from the sensors and calculates the user's temperature and SpO2 levels. It then sends those values to the LCD screen in the user display section to be printed for the user to see. It also will send a signal to turn on one of the three LEDs based on the measurements of the user and what range they fall into. For example, if the user has a good temperature and a good oxygen saturation level, it would turn on the green LED. This allows the user to know that they are good to go without having to actually read the values if they are not interested in that. Additionally, the LCD and LEDs can be used to provide further instruction and other information to the user.
This is the block diagram for our network subsystem. To add network connectivity to our project, we're using a Raspberry Pi 3B, and this will allow us to communicate remotely with the device to track usage information, send messages to the LCD, and to send a ping to the device to see if it's still on and working.
Okay, so this is the block diagram for the UVC. So the UVC will be powered by the STM32 boards. I've missed the arrow from the STM to the UVC in the graph, but I'll make a new one like later on. So the STM board will drive the UVC for a certain amount of time, and it will show how long does it take to sanitize. And also the LEDs will give a signal to show the status of the sanitizing process. For example, like the green is safe to use and the red is not. Okay, these sensors are what we're going to use. So the SpO2 sensor is using the I2C protocol, and it's moduled since the SpO2 sensor itself is very tiny and it's almost impossible to solder on it. And for the temperature sensor, as mentioned before, it's contactless, and the measurement resolution is of 0.02 degrees Celsius. So that's why we choose it. So for the testing plan, Vincent is going to test on the user display in the microcontroller. Thomas will be testing on the network and SpO2 sensor and power source, and myself will be testing the UVC and the temperature sensor. So for the implementation of testing, so we all have our ability to test components individually, and we can share our codes through the GitHub. And also we can go to the campus to combine all our individual components, and if we get access to the labs.
So this is our Gantt chart for ENEL400. As you can see, the last day of classes is December 8th. And for all of our activities, we have 100% completed them for ENEL400. This is our Gantt chart for ENEL417. It outlines the major activities that will be going on throughout the semester, with classes starting on January 1st and ending on April 15th. The important dates for this Gantt chart are outlined on the next slide. So these are the important completion dates outlined for our project. We plan to have the development of modules completed by January 25th. We plan to have all of our parts ordered by February 1st. We plan to have the PCB manufactured by February 14th. We plan to have all of the modules tested by February 21st. We plan to have the integration of all of our modules together completed by March 8th. And we plan to have our final project testing completed by March 21st. We plan to have our project demonstration ready for March 29th. And the project day is on April 10th, with our final report due on April 12th.